So let's do the integral of sine of 8x over sine of 2x. We have sine terms with different angles as the arguments, which we'll have to deal with using trigonometric identities. But before we do that, let's just simplify this a little by doing a u substitution. We would like to substitute u equals 2x, since 8 and 2 have a common factor of 2, which allows us to rewrite the integrand in terms of u, where u equals 2x. However, this means du would equal 2 dx, so we would need a constant factor of 2 in the numerator to prepare for the substitution. So let's just take out a constant factor of 1 over 2 and rewrite this as 1 over 2 times the integral of 2 sine of 8x divided by sine of 2x dx. So we're now ready to do the substitution. If we let u equal 2x, then du equals 2 dx, and if we substitute this into the expression, this becomes 1/2 times the integral of sine of 4u over sine of u du, since the 2 dx becomes du, and sine of 8x becomes sine of 4u, and sine of 2x becomes sine of u, since u equals 2x. So we should now rewrite the sine of 4u term in a more workable form using the identity sine of 4x equals 8 sine of x cosine cubed of x minus 4 sine of x cosine of x. We basically got the formula for sine of 4x by first applying the double angle formula to the expression sine of 4x to rewrite it as 2 sine of 2x cosine of 2x, then use the double angle identities for sine of 2x and cosine of 2x to rewrite the entire expression, and once we simplify the result, we get the expression we want. So if we use this identity, the numerator becomes 8 sine of u cosine cubed of u minus 4 sine of u cosine of u, and the denominator is still sine of u. If we distribute the division by dividing each term in the numerator by sine of u, the integrand becomes 8 cosine cubed of u minus 4 cosine of u. If we multiply the constant of 1 over 2 into the integral, we end up with the integral of 4 cosine cubed of u minus 2 cosine of u du. We now have a sum of terms as the integrand, which means we can integrate cosine cubed of u and cosine of u separately, then add the results along with the constant multiples. But I'd like to do something different. We can first factor out cosine of u from each term to rewrite the integrand as cosine of u times 4 cosine squared of u minus 2. And if we use the identity, cosine squared of u equals 1 minus sine squared of u, which comes from the Pythagorean identity, then the integrand becomes cosine of u times 4 times parentheses 1 minus sine squared of u minus 2, and if we expand and combine like terms, the expression inside the parentheses just becomes 2 minus 4 sine squared of u. The integrand is now an expression with a single cosine of u term multiplied by an expression entirely in terms of sine of u, and we know that the derivative of sine of u is cosine of u, which allows us to do the substitution v equals sine of u, which implies dv equals cosine of u du. So if we substitute this into the integral, we get the integral of 2 minus 4v squared dv, since cosine u du becomes dv. If we integrate this, this becomes 2v minus 4 over 3 v cubed plus c. If we substitute sine of u back in for the v, this becomes 2 sine of u minus 4 over 3 times sine cubed of u plus c. And we originally substituted u equals 2x. So if we substitute 2x back in for the u, the final answer is just 2 sine of 2x minus 4 over 3 times sine cubed of 2x plus c.